Hello, everyone. Welcome to today's session. So my name is Audrey Bian. I am the Principal Product Marketing Manager at Broadcom, and it's great to be here with you today. I'm joined by my coworkers, Timmy, Carr, and John Andrechak. Tim and John, would you like to give a brief introduction of yourself to the audience?
Yeah, hey, I'm Timmy Carr. I'm a product manager focusing primarily on the VKS stack here at VMware.
Everyone, John Andrechak. I am a technical marketing manager, also focused on VKS stack.
It's a pleasure to present with you too. So today we will walk through how vSphere Kubernetes Service 3.5 release enable platform team to build standardized Kubernetes environments, deploy clusters reliably, and simplify lifecycle management without introducing fragmentations or operational risk. So let's take a look onto this agenda. So in today's agenda, we will talk about how our goal aligns with our customers' challenges. vSphere Kubernetes Service, we will go with VKS today, and the VMware Cloud Foundation will go with VCF in this session. How VKS are built in the VCF and also with the cloud services. We will talk about three key personas in VCF and also customer use cases. Then I will hand over to Timmy talk about what's new with the VKS 3.5 and a deep dive. The last is John is going to give us a demo. Now let's get started. So most Kubernetes environments don't fail on a day one, but customers we see they struggle on a day two, such as like upgrade, scaling, consistency, operational guardrails are where complexity shows up. So when it comes to modern apps, there are what customers are looking for. So I categorize them actually. You can see there are like 6 bullet points here, but I categorize with them like 3. First is we will talk about consistency and a unification. So customers, they need a consistent management of VMs and Kubernetes clusters. So they cannot afford to have like 2 separate operational silos. When it comes to the unification, so of course, they are demanding for a unified platform. They wanted to integrate functionalities and a consistent experience regardless of the workload type. So in the section 2, I would call them like speed and experience. First, the access. So developers and platform engineers, they need easy access to the infrastructure services, and which we call like self-service for them. And for the productivity, so it directly tied to increase productivity for platform engineers and the DevOps teams. They need to remove the frictions so they can focus on coding and deploying. So the third part is enterprise standard. So customers, they need operational efficiency and a peace of mind knowing their workloads are safe. And also, most importantly, they want to stay with the current Kubernetes versions, which align with our upstream community. And at the same time, having the flexibility to stay on the older version if needed. So with that, let's take a look about our goals. And also I have like 3 boxes here. It's aligned with the 3 sections I talked about. First, we want to give customer a simplified deployment experience by bringing containerized and VM-based workloads onto a single consistent platform. The second, we want to address the security concerns by reducing attack surface and increase the patching efficiency for stable deployments. The last is, maybe you already heard, we have this VMware private AI framework. So we have taken a platform approach to AI workflow deployment. This helps our customer with speed and agility in deploying these data-intensive workloads. So on this slide, it's illustrate how VCF deliver a built-in Kubernetes runtime through VKS. So at the bottom, you can see it's VCF will provide compute, storage, and networking layer, ensure performance, security, and efficiency at the infrastructure level. level. And with vSphere Kubernetes Service, we call VKS, which provide an enterprise-ready Kubernetes runtime for customers to deploy and manage their modern workloads. It also includes a set of CNCF open source services to further facilitate that. So there is a wide range of services such as private AI service, VM service, network service, storage, and data services, making VCF a complete platform for both VMs and containers. So at the center is our multi-cluster management, which simplifies operations across environments with lifecycle management, policy enforcement, and governance, which is critical for organizations. They want to scale Kubernetes across teams and clouds. And this environment, we support like 3 key personas. First is cloud admins, which manage the underlying infrastructure resources with ease. And for platform engineers, they can configure and maintain Kubernetes clusters and services. For the developers, when they consume APIs and they have the self-service tools to build modern applications. And also, which is important, I want to mention here is our architecture is extensible and open, enable integration with any CNCF compliant third-party services, giving customer choice and flexibility. And now let's take a look on the VKS. So this is the runtime I was talking about, and let our customer deploy upstream aligned Kubernetes clusters on demand. And also VKS make Kubernetes cluster deployment quick and easy. It's only up to you whether you are decided to deploy a big cluster with a lot of resources allocated to it, or you prefer to deploy a smaller cluster to provide a better isolation for your applications. And thanks to the services such as network service and storage service, you can seamlessly integrate with this underlying virtual hardware. You can also deploy multiple Kubernetes versions, so the teams, they can use them for experimentation or testing. For example, so when you try to validate your applications on a newer version of Kubernetes, so you can do so with the VKS. And then at the same time, you stay most of the workloads on the previous version. So again, all you can do is alongside all these workloads while having the same management experience. Okay, so this is the slide. I call it like a key takeaway because we mentioned a lot of concept here in a slide, but I want to just summarize each of them with a very short sentence, such as when you think about VCF with modern workloads, we talk about it's a single platform to run all workloads. And for VKS, it's a built-in Kubernetes runtime in VCF that orchestrate containerized workloads for our customers. And the VCF also include a comprehensive set of cloud services to build modern containerized workloads. The last is the cluster management I mentioned earlier, which delivers control, efficiency, and security to the platform team. So now, if you remember, I mentioned like key personas in our agenda and also the slide talking about the VCF and the VKS. Now I want to kind of extend it to this like 3 key personas and what's the benefit we bring to them. First of all, cloud admins. So because we have a single platform for the VMs and the containers, so VCF provides this single platform to run traditional and modern workloads. It's simpler to operate, fewer silos, and it's consistent tools across all the environments. And the second is a simplified Kubernetes operations with existing skills. So instead of retraining, you can now extend your VI admin existing skills and to manage Kubernetes lifecycle, and from provisioning, upgrading, and into scaling to build into a familiar workloads. The third part is policy and governance and control. So cloud admins, they can retain the control they need to enforce compliance and operational consistency, centralize the policy and governance, ensure team they can move fast without compromising standard. And we also have multiple Kubernetes versions to support different different versions of clusters. So we support up to like 3 previous Kubernetes versions, not just the latest one. So this flexibility is critical for avoiding disruptions when developers, they need a little bit more time to validate or migrate their workloads. The last but not least is the 6 layers of protection. So as organizations, we increasingly adopt the Kubernetes for modern workloads. So security and force in isolation becomes very important. So traditional Kubernetes platform only provide some a basic layer of isolation at the namespace level, and leaving the enterprise exposed to security risks, noisy issues, and operational failures. So which this is not going to happen with our platform. The next one is the platform engineers, which is also our key persona. For them, they benefit from a CNCF certified Kubernetes runtime, which runs all the apps. So this ensures VCF provide a CNCF certified Kubernetes with fully compatible with the community. And the customer, they also avoid the vendor login and maintain the capability to stay on the multiple Kubernetes versions, as I mentioned. Now we also offer the 24-month support for all Kubernetes minor release. I think Timmy will dive into that later as well. So because we see one of the biggest pain for our platform teams is they need to keep the pace with Kubernetes fast release. Now we provide with I'm sorry, 24 months of the support for this for the VKR releases. So this really reduce the pressure for them and also stabilize the environment, free up the team to focus on delivering value instead of constantly planning upgrades or fixing all the patching issues. And the third part is a built-in integration with our platform engineering tools. So we provide a built-in GitHub integration with tools like Argo CD, Ham, and this makes it easier for a team to push code automatically, deploy apps, and then maintain a consistency across the clusters. And also we want to talk about the multi-cluster cycle management policy and a backup at a scale, which is our VKS cluster management deliver the control and efficiency and security to the platform team who are looking to simplify Kubernetes operations. And the last one is a unified set of APIs, which across all the building block services include the private AI. So this benefits our developers and the platform engineers get a unified interface, accelerating their integration, automation, and innovation. And the last is our decision makers. They are equally important. For decision makers, the first thing we always want to talk about a lower TCO. With VCF, our containers and the VMs are running on a consolidated infrastructure, which really eliminating, the silos and running like 2 different platforms, and then reducing the license cost, also the operational overhead. It's really at the same time, the customer, they don't need to worry too much about the infrastructure complexity. And the second part is a faster time to value. We deliver faster application delivery, so organizations, they can move from ideas to production more quickly. This means like the transformation projects deliver value sooner and start producing ROI earlier. And they also, for decision makers, they care about the security and the compliance. Like I mentioned earlier, we provide a better protection against the fraud and the cyber threat, which also in data in VCF is encrypted end-to-end with both at risk and intrinsic. The last and the fourth thing is our open source leadership. Broadcom and the previous also VMware is being among the top 5 contributors in the past 5 years in CNCF community. We actively contributing support and participate in the CNCF project. which include in the VMware time, we originated the Kubernetes project, and then we also support the projects like cluster API, and also we participate in the Kubernetes advocacy and leadership thought leadership events. The last one is a skill gap. It's also related to the cost. We see a major barrier to the modernization is a skill gap. How to retain the staff and avoid to hire other like Kubernetes experts, which can be costly and the process can be slow. With VCF, we ensure existing teams, they leverage familiar skills when also manage Kubernetes, which closes the skill gap and reduce the risk, accelerating innovation by making team more productive from the day one. Now let's take a quick look on the use cases here. The first is the app modernization. So we realize that many customers, they are modernize existing applications. They need a consistent networking security across and also the access policy across teams without introducing operational overhead and the regulated workloads. So industries like financial services, healthcare, and governments, they require strict security and compliance and data sovereignty control. They need isolated Kubernetes clusters and meet their regulatory requirement without custom engineering. So which we can provide customer with that. In AI workloads, which is really hard. We all talk about AI. So organizations, they are rapidly exploring Gen AI and private AI use cases, but then also need an enterprise-grade infrastructure to run AI securely. The first one is for the cloud deployment. We know customers, they have workloads everywhere across, like on-prem, in the cloud, and the edge. So they also want to avoid silos, duplicating tools, and refactoring. The last is the dev test environment. I mentioned a little bit about that earlier. So, for example, developer team, they need the ability to spin up and tear down isolated Kubernetes clusters quickly without waiting on the IT ticket or manually wiring the infrastructure. Now I will hand over to Timmy. We'll dive into VKS 3.5 release and the features. Timmy.
Thanks, Audrey, and thanks for the overview. So on this slide, I just want to cover off on some of the new capabilities that we're bringing as a part of VCF, as a part of VKS 3.5, including VCF in your stack. So with every release of VKS, we include a new version of Kubernetes. And just note the timing for our launch. We're usually shipping within 2 months of when upstream releases a new Kubernetes minor version. Expect that cadence from us. We'll get into the support timeframes for our Kubernetes releases, which we call VKRs, but know that with that 1.34 release, we're going to provide 24 months of support for that. Just included out of your stack. Nothing additional required of you. If you have a problem, you need support on this version for 1.34, you have 24 months of support. So let's talk about some of the capabilities that we're bringing into the stack. We've enhanced our ability to do configurations of components of your Kubernetes stack. So specific kubelet arguments that you might need to make in your stack, or flags that you might need to make with the API server, or configurations that you would need to make with etcd in your stack. We've exposed those sorts of commonly configured variables in VKS 3.5. We've included and simplified lifecycle management of the things that we call add-ons for our clusters. I'll get into more details about that a little bit later. We've also, as a part of this release, incorporated Cluster API v1 Beta 2. I'd like to dig into Cluster API for just a second here. You see that we've incorporated v1 Beta 2. I'd like to tell you first what v1 Beta 1 included. If you look at that release was all about taking Cluster API. And what is Cluster API? That is the upstream machinery that we use in our stack. And when I say upstream, I mean the Kubernetes community-driven machinery that allows us to lifecycle and operate your Kubernetes clusters. It is the Kubernetes community way for deploying and managing these clusters, and it's pretty industry standard across Kubernetes distributions. We're proud of the heritage of Cluster API and have been a part of that from the project's inception and maintain leadership in that space. It's a key contribution area for us in terms of how we want to give back to the Kubernetes community. As a part of the V1 Beta 1 release of Cluster API, one thing was clear. We wanted to take this stack and make it completely declarative so that it would align with lifecycle of Kubernetes clusters in a very GitOps forward approach, right? V1 Beta 2 really takes that to the next step and solidifies that vision for the CAPI community. There were some enhancements to make the Cluster API machinery more adequately able to deal with your GitOps workflows for how you would want to lifecycle your clusters in your stack. And those made it into V1 Beta 2 and are, of course, in our product. The other kind of interesting things about V1 Beta 2 that you might note here is that we're looking also at how we can do more enterprise-focused things for Kubernetes cluster lifecycle. Okay, Timmy, what are the enterprise-focused things? Well, some of the things that the community is looking to drive here are things like chained upgrading from one version of Kubernetes and through a couple versions of Kubernetes, right? Now, while we don't have that in VKS yet, we've embedded and we've worked with the community to contribute the needed machinery so that we can drive these into product over time. So we're making that down payment in the Kubernetes community to make sure that we're able to do that. I think the one final sort of thing that I would call out here is that we have really made conditions in Cluster API kind of a first-class thing. Like so, previously, conditions were maybe somewhat unstandardized in how we work with those in the community. We have better standardized conditions for status of objects that are happening in Cluster API, as well as error reporting in Cluster API. So when you're looking at your logs for how your clusters are rolling out, we've improved what you're seeing in the logs for how your clusters are operating. This V1 Beta 2 inclusion is actually a really key capability here and something that we're really proud of from a community perspective. I'd like to then talk just a little bit about how we're making our clusters, our VKS clusters, easier for your use cases, right? So as a part of our life cycle of clusters in VKS, we want to make it safe for your workloads to exist from a version of Kubernetes and into the next version of Kubernetes. We've included pre-checks for things like pod disruption budgets in the 3.5 release. This feature is going to make that we are going to roll out new nodes of your cluster, and you need to have pod disruption budgets in place so that you are sure that your applications will not be impacted by the fact that we're rolling out these new nodes. Rolling out new nodes as a part of a rolling upgrade process is a community standard way of doing this, and ensuring that pod disruption budgets are enabled in your environment is also community best practice for ensuring that your application is resilient to the rollout of our infrastructure upgrades. I think the other thing that's of note is that we're making improvements for your support experience. Should you have problems with your VKS cluster, getting your VCF and VKS logs all bundled up, we've included that in the stack. So let's go on to the next slide and let's talk a little bit about what we've done from VKRs. So you'll see from VKS 3.4 to 3.5, we've included a new version of Kubernetes. We've included 1.34. To run 1.34, you're going to need to run VKS 3.5. All right. And you'll see another couple things. On the next slide, we'll talk a little bit about the 24 months of support policy, but you'll see in VKS 3.4, I've highlighted that 1.33 kind of in gold there, those letters. That version has 24 months of support. You'll see as we release VKS 3.5, 1.33 and 1.34 are all following that 24-month support process. And as we release that next version of VKS, what you'll ultimately see is you'll see all three of the VKRs that we include in our stack include that 24 months of support for the stack. And so what we're doing is we're providing you a longer runway for the version of Kubernetes that you're running in your data center, because we know that the community standard probably isn't completely aligned with how enterprises run their software. Ideally, you're keeping up to date, but we also know that there's commercial applications that prevent people from expeditiously upgrading. This is our answer for that here. The one other note is that VKS 3.5 requires you to upgrade your supervisor to version 1.30 or higher. That's an operation that you can do inside your vCenter infrastructure. And you would do that via the workload management tile there. You'll upgrade supervisor to 1.30, and you'll be able to run VKS 3.5. Let's move on to the next slide and talk about the support timelines a little bit more in a little bit more details. Okay, so we're calling out 24 months of support. One key about this is you'll see version 1.33 and 1.34 both include 24 months of support. Now, in some cases, if you're working in a cloud, or if you're working with other distributions, you'll have different types of support. Here, you'll have like you'll have like 8 months of this type of support, and then another 4 months of this type of support. We want to try to simplify that message for everybody. Here, with 1.33, when we released version VKS 3.4, we included 1.33, and we included that with 24 months of standard support. This is what we're saying. This is our standard support term for Kubernetes 1.33. As we release Kubernetes 3.5 or VKS 3.5, we included Kubernetes 1.34. This is the standard support time frame for us. And so for what you're going to really see is you're going to get all of the patching of critical security vulnerabilities. You will get upgrade assistance between these versions, and you'll get support if you have problems with the version of Kubernetes that you're dealing with. Separately, you'll get patch releases. We are on a bi-monthly patch cadence in our stack. So as you need to upgrade a patch version of Kubernetes, you will receive a patch version of this, on a bi-monthly cadence in our stack as well. So you'll have the ability to upgrade those Kubernetes patch versions to the most recent patch, should you find some sort of bug that the community's fixed as well. All right, let's jump on and let's talk a little bit about the unified add-on management. Unified add-on management is a pretty big deal. This is our down payment on how we are going to manage and lifecycle the components that we add to your VKS cluster to give it more enterprise value. Let's take an example of Cluster Autoscaler. One of the unique challenges that Cluster Autoscaler has in working with a Kubernetes version is that there is a version of Cluster Autoscaler that is required for each version of Kubernetes. And so from a dependency management perspective, you need to align a certain version of Cluster Autoscaler with a certain version of a Kubernetes miner. Using our add-on framework that we've been there, add-on APIs, what we're able to do is we're able to manage that dependency for you. We are able to note that as you are upgrading your cluster from one Kubernetes miner to another Kubernetes miner, that you also need to upgrade Cluster Autoscaler's version to be applicable to that version of Kubernetes you're upgrading to. It's that sort of dependency management that we want to build into our stack. And the Autoscaler is one example. Every one of those other add-ons that you previously saw in one of Audrey's slide up there can be managed via this add-on framework. And in fact, we're going to take this and we're going to build this into our UI as well. So as you're looking to add different components to your VKS clusters, you can simply log in and click to add to your clusters in your environment, or you can manage these via policy within a namespace, within a supervisor namespace in your environment. So there's a lot of different capabilities that we're driving out of the box here. Now, today this works with our packages that we ship. We are looking to, but This can also work with anything that is potentially a carvelized package today. In the future, you can expect to see us extend that model to be more applicable for the other formats that are out there as well. And so this is just our down payment on how we're going to manage dependencies of these things that we add to our VKS clusters. Okay. And with that, I'm passing it over to John.
All right. Hey, everyone. In this demo, I'm going to walk you through the life cycle of a VKS cluster. So along the way, I'll highlight some of the new features that we brought in with VKS 3.5. And the screen you see here is the VCF automation console. So once you're authenticated, we land on the main dashboard, and this provides an overview of the different services and resources available to us. And so the first thing that we'll do is we will create a new cluster. There we go. Okay, so we're going to create a new cluster. We'll go into Kubernetes. We will click create, and we can create a cluster in two types of ways. We can do easy mode with just the default configuration, click next, next. As you can see here, we have 3.5 here for the cluster class and Kubernetes 1.34 at the latest. In this example though, let's do a custom configuration. So the first thing we'll do is rename our cluster. Let's call it VKS01. You see the cluster class here as well. The Kubernetes releases that are available to us, and let's select 133. And the reason that we're going to do this is to make sure that I'll show you how to upgrade the cluster as well. So we have a lot of different options here. We can add labels, taints, volumes. We can change our cert rotation. I'll change this to 180 days. And a lot of other options, including some for Ubuntu Pro, networking options, configuration, and storage configuration. We can create this cluster with all the defaults. So we'll just click next without entering anything. And now we're going to take a look at our control plane. So we have a couple of options here. We can decide how many replicas we want. In this case, we'll do one. And the VM class. So what size do we want our cluster to be? We'll select the best efforts medium in this case and use Ubuntu 2404 using our default storage policy and click next. Now, node pools. So you see there's one that is automatically created for me. I can add another node pool with a different configuration. And this is a really neat thing about VKS is we can have multiple node pools with different configurations. So if you have a different operating system or different size requirements, you can add different node pools. In this case, we'll just edit the existing one. And let's change the VM class to medium and OS image to Ubuntu and add labels and taints as well as volume. So we'll add the label to this one as node Ubuntu. Click add, next, and add a volume. And you might wonder, well, what would you need it for? Well, say, for example, you have AI or ML workloads that require the NVIDIA GPU operator that needs a bit of extra space. So we can add that here. And you see that I created it with 5 gigs and it's right there. Let's review it. And it looks good, so we can proceed. Clicking next, you can see that that's all we had to do. And on the right side of the screen, our YAML manifest was created automatically. So all of the different configurations that we chose automatically populated. And you might want to download this if you, say, for example, want to use GitOps for your environment. So I'll download this and save it, and then we can proceed with finish. Okay, so we have our cluster. It's getting started. Next, we're going to take a look at cluster management once it's up and running. So here in cluster management, once the cluster is up, we can get to it through through Kubernetes management that's under the manage and govern section at the top header bar. So here we see a lot of different information, and what's really neat about this is it was our cluster. You saw I didn't do anything. It just is automatically onboarded into the Kubernetes management capability, and we have a dashboard here that shows our CPU, RAM, component health, worker node details, and information on the agents in terms of monitoring. At the bottom, you'll see data protection as well. We could enable data protection for this cluster and set that up really easily. On the left side of the screen, you also see we're looking at clusters now. We can configure policies and add additional configurations. For now, though, we'll just take a look at the top header bar and go into nodes. And you can see we have two nodes. We have our control plane and our worker nodes. Let's take a look at resources. You have all sorts of ways that you can look at this by namespace, object. I'll just populate deployment. And we can see all the deployments we have on our cluster. And now take a look at add-ons. So this is cluster management, makes it really easy to extend our cluster functionality. And this is what Timmy was talking about. We can click our add-ons tab. And here you can see installed add-ons, available add-ons, repositories, and we don't have anything installed. We'll go to available, and you can see what's available here. We have all of these different packages that we can install with the click of a button. So let's pick Cert Manager. Okay, so we have Cert Manager. We can check the version, and taking a look at this, we can also configure it within the table. We can see the default values and override values to make an overlay YAML, but that is made automatically. But in this case, in a lot of the packages, we don't need to do any configuration, and we can just type a package name, say go, install. It's installing, and we can check it out in our resources tab as well and see if it's been installed. So I'll just take a look at the namespace of for Cert Manager and see if it's come up. And it has, and so we see it's up, it's healthy, running in just a few seconds there. And now we can go into our CLI and see what's going on. Okay, so we're in the CLI, and what you see here is the VCF CLI. And you can see I'm in the VCF automation context right now. I have two clusters there as well, VKS 01 and 04. And let's use the context for 01. And you can see it's pulled it in. It was looking for recommended plugins. And a neat thing about the VCF CLI is it's plugin based. So we don't need to update it. And it checks for updates to the plugins or recommended plugins when we authenticate. So let's take a look at our cluster. Let's take a look at the namespaces. You can see Cert Manager is there. We can look inside Cert Manager, and let's see what it was deployed through the add-on. We have our pods, different services, the deployments, replica set, and now we're going to take a look at scaling replicas. So the thing with scaling replicas is it's not new for 3.5, but I want to show it as a part of our life cycle as well. You can do this automatically. I'll do it manually in this step here. And it's really easy. You just go to your node pools and click at it, and we'll change replicas to 2. And it's you can see it's spinning. We can go into our CLI now, and let's change our context to the VCFA automation context. And this can see all of the different clusters that we have. And let's take a look. All right, so we have 2 clusters here, VKS 01, 04. And you can see right now that 01 has 1 of 2 workers right now. It says updating. So let's get some more details on that. Awesome. So taking a look here, you can see the warning because something is happening on the back end. An additional replica is spinning up. And let's take a look again and see what the status is. Same command. All right, it's up. We have 2 replicas now. And now for the fun part. Now that we have replicas, let's update our cluster. So we'll take a look inside. Or we'll verify in the UI first and go to node pools. We'll see that that's 2 replicas. And now we'll upgrade the Kubernetes cluster to the latest version from 1.3.3 to 1.3.4. And so taking a look, this is 1.3.3, what we just installed here. And all we have to do is click on the dots, click upgrade, and it automatically will tell us which versions are available for us to upgrade to. If I had taken the earlier version of 1.3.3 for this, or a 1.3.2, you would have seen a lot more versions than 1.3.4 here. Upgrade. And let's take a look. Okay, so it says 1.3.4 when ready, and that was pretty fast. But we can check out what's happening on the back end in the CLI. Let's run that same command and see what's going on. All right, so it says 1.3.4. Status updating as well right by it. And you see below, on the control plane, you'll see 2 machines. One is ready for true and one is ready false, and that's VM provision starting. So starting the upgrade process to just run automatically and ensure no downtime for our clusters. It's all happening on the back end. We'll wait a little bit and we can see the status of it. Awesome. So there you go. We updated our cluster to the latest. Everything's running. Ready state's true for everything. And I don't have it for this demo here, but let's say I had added pod disruption budget of minimum, to have the no availability of less than or equal to 0, then that would mean that when I tried to upgrade, I would get an error. So that was the new feature with 3.5. And overall, this is the whole life cycle, and we got to see creating a cluster, accessing it, going into cluster management, deploying an add-on through the cluster management service, and then scaling out that cluster and updating it to 1.3.4.
Thank you, Timmy and John. And thank you. We want to thank the audience for joining our webinar. Hopefully, you learned something new and enjoyed our content. So this webinar will go live for on-demand consumption today or tomorrow. And I thank you again. See you next time.